Okay, so welcome back to the channel Glorified Education. Today we are going to discuss basically the further in the chapter, that is we are going to discuss the limits part 4 starting from the question number 16 basically. So let's just start. We're just opening this screen and yes, it's fine. Now we can start. So I was saying like 16 number question. So without wasting our time, let's begin. The function log 1 plus ax minus log 1 minus bx upon x is not defined at x equal to 0. The function is not defined. Even we can put it and check it. Like it will be log 1 minus log 1 upon 0, 0 upon 0 format. So it's not defined. The value which should be assigned to function at x equal to 0 so that it's continuous at x equal to 0. So it means like continuous at x equal to 0 basically means, so this is a question basically from the continuity chapter. So is LHL equal to RHL or equal to like I say f of a, and that should be equal to finite. That is a one way to define continuity. Other way we simply say limit x tends to 0 because 0 we have here, f of x should be equal to f of x directly if I don't apply the LHL and RHL. So I'm going to use this way and going to find the answer. So let's see. So if I'm going to use this way, I'm going to find the answer. Let's see. I'll be applying the limit. So limit x tends to 0 log of 1 plus ax minus log of 1 minus bx. So over x if I divide separately. So what I'm doing, I just multiply a in denominator and a in numerator, a in denominator and a in numerator. So if I see few things, just see the few things now. Like this particular expression is the format of my answer actually. Yes, is the format of my answer actually. That is, if I see log, actually I've done one mistake here. Let me just correct that mistake, then we will see. Actually we have minus x. Okay, fine. So I'll be doing this b here actually. So here we will having b here and b here, and minus we already have. Now if we can see log 1 plus ax over ax, that is 0 by 0 is becoming. So this particular, this pink wall will goes to 1. So 1 and a multiplied, and then we have minus. Now here I have minus, so I need minus downwards also. So minus multiply and this minus become plus. So a plus b is something which we get. A plus b is something which we get. So a plus b is the answer. Let me just repeat it. The minus downwards like in denominator. So I need, and in this particular I have minus here. So I need minus in denominator. So I multiply in numerator and denominator and I get the minus sign. So that is also like 1. So 1 on 1 a plus b. So none of this will be the answer where I will be getting the a plus b actually, because none of the answer is a plus b. Fine. Now let's move to f of x sine of. So this question we have done already also. So like let me just do it once more. Basically earlier also we have applied that our limit rule, that is L'Hospital. So let's find out. It will be cos of e x minus 2 minus 1, and for e you will have e x minus 2 as it is. For log 1 by x minus 1, so I went x minus 1, and then I just put a 2 here. So cos 1, cos 0, that is 1. E power 0, that is again 1. And 2 minus 1, that is 1. So I got the 1 answer. Earlier also we got 1. In the same question, we got the 1 answer again. Now let's move to the other question. What is the value of the limit this? Now it is very interesting. If you see the limit here, let me just color it. Okay. This is actually 1. Because I know if the degree of numerator and degree of denominator is actually equal, so we actually take the ratio of their coefficients. So 1 by 1 is actually 1. And if I see this power is actually going infinity. So the form is 1 power infinity. And for 1 power infinity, we all know we have to take e limit x tends to infinity, gx as it is, that is x plus 4 as it is, and f of x minus 1, that is x plus 6, x plus 1 minus 1. So it will be simple. If I solve it further, it will be e limit x tends to infinity, and that will be x plus 4 into x plus 6 minus x minus 1 over x plus 1. So this x cutouts, and I will left with 5. Now it's basically becomes 5 only, and other format is x plus 4 and x plus 5. That is basically like numerator and denominator degree is same. So 1 by 1 basically coming out. So I can directly say e power 5 is my answer. So e power 5 is my answer. Okay, fine. Now let's move toward the other question and let's see. So limit e power 1 minus x. It is basically 1 minus x. Let me correct it if it doesn't seem feasible. 1 minus x. E power 1 minus x. So if we see e power minus 1 minus x, and we actually already have that d part, that is does not exist here. So we have to check LHL. So if I'll be checking LHL, I'll be having e power, see, limit x tends to 0 minus basically e power minus 1 over x. So if I put minus 1 over x, I'm putting like simply, let's take 0 minus means minus 0.0001. Already we have minus, so minus minus become plus. So 1 over infinity is 0. So e power 0 will be 1. Now if I talk about RHL, it is limit x tends to 0 positive e power minus 1 by x. Now try to visualize this. So 0.000 is something that is 1 by infinity, and minus we have. So that is, minus infinity, e power minus infinity is something 1 over e power infinity, that is 0. So LHL, RHL are coming different. That means the limit does not exist. Now let's move to the last question of today's class. Then we see other questions in the next session. So what is the value of k for which the following function is continuous? So this is like in Pathfinder, we have limit, continuity and differentiability as a one single chapter. That's why the question of limit, continuity also coming. So this is basically, let me correct it if it's look different. It is x cube minus 3x plus 2 in the that is in the numerator, and x minus 1 whole square in the denominator. So for x not equal to 1 we have defined this, and for x equal to 1 we have defined this. So we'll be simply applying the limits. So that is limit x tends to 1. So for x, let me just check, x cube minus 3x plus 2. Okay, fine, and x minus 1 whole square. So if I put 1, so 1 plus 2, 3. So x minus 1 is one of the factor of this, I can see, and other like I'll be finding by just dividing, because okay, that's fine. I'll be finding other factor by dividing, and other one is x minus 1 whole square. So this one will cancel out. Now let's see the other factor of x minus x cube minus 3. So we'll be seeing on the next page. So this is what x cube minus 3x plus 2. So I'll be finding with x minus 1. So that will be x square, x cube minus x square. So minus plus. So I'll be getting x square minus 3x plus 2. And again, if I say it's plus x, sorry for this, plus x. So I'll getting x square and minus x. So plus minus, this will cancel out, minus 2x plus 2. So it means minus 2. So I'll be getting minus 2x. Yes. And this is plus 2. So if cancel out, all will cancel out and becomes 0. So it means other factor is simply, if I just take you back, just a minute. So other factor is that was x square plus x minus 2. X square plus x minus 2. Now if we find other factor of x square plus x minus 2, so the factor of I can easily find like just by splitting middle term. So let me just find it here only. Let me change the color. So it will be basically one is x minus 1 and other is basically, if I see, if I put 2, 2 will not work. 2 minus 2, yes. Let me just check it out. Other will be, we can apply Sridharacharya rule directly. So other will be minus 1 plus minus root of b square 1 minus 4 into 2 upon 2. So it will be like plus here. So 1 plus minus, I'll having 3 over 2. So minus 4 over 2, that is minus 2. So other is x plus 2 basically. So I get x minus 1 into x plus 2 over x minus 1, and limit x tends to 1. So this will cancel out and x plus 2 will become 3. So my answer will be 3. So thank you so much for attending this session. We will be back with more videos in the next session, and stay continue to this channel, and please subscribe and like, share, whatever you can do, please do. That's fine.